Wait.
Somebody has a question, 1-5, question 1 and 2. Let's take a look. Section 1-5. All right, let me get back there. Here we go. Oh, it's my old favorite. Okay. I feel like some band up on stage saying, let's play some of our old hits. So one more time. What's the very first? Well, the very first part of this problem is number 1, where you have to create points, because you can't graph points until you know what they are. Hold on.
Bluetooth mode.
Let me do this.
Bluetooth.
All right. So this will be the last time I'm going to talk about this. Okay. So once you create points, and we already talked about these, is the first coordinate is hours after midnight, and the second coordinate is temperature. So they're basically already points. I'm just converting them to be like this, right? So I'm going to have to get up to 81 on the y-axis, so on the temperature axis, right? So one of the most important things about graphing is picking a good scale. So do I want to go by 40? Is that a good idea?
No, it's way too small.
Holy shit, it's way too small. When I graph this, it's going to look like a straight line, basically. So the way you determine what scale to use is you want to end up with 80 somewhere up here, right? And now I told you guys to kind of take a guess and see. You could do something more mathematical. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I got 12 little tick marks, right? And I want to get up to about 80 something. So if I do 80 divided by 12, that would give me a rough idea of a good scale to use. Or you could just do like we did before and just kind of guess, well, let me try 5. And then you notice 5 won't get you up to 80. So then you try 10. Some of you guys use 9. Some of you guys use 8. I love it. Does anybody have a question about what I'm talking about right now? So this idea of scale is crazy important. If you pick a bad scale, your graph is going to suck no matter how careful you are plotting the points. Okay. All right, I like it. And then you have to figure out a scale for this one. That's a little bit easier. And I'll remind you guys that we did figure 2 would be good because that'll get me up to 24 up here. And then to plot the point, for example, this point is 462. I would just find 4, and then I would go up and find wherever 62 is, and I put a point there. That's it. That's it, right? Is that okay? So let's see. If I use the scale of 10, oops, shit. If I use the scale of 10, 20, 30, 40, 50, 60, 70, 80. See how 10 is not the best scale to use? Because look at all this unused space. But if I did use a scale of 10, then the point 462, 30, 40, 50, 60 would be about right there, right above 60. Is that cool? There's the point 462. So once you set up a scale for both axes, you can then just plot the points wherever they fall. Oh, sure. Okay. That could happen very easily in this book, the overthinking thing, because a lot of the questions they ask are really simple. They're so simple that you're like, there's got to be more to them. This one is not necessarily that. It depends on how comfortable you are with graphing. All right. I like it. Anything else, guys? Did I miss anything? No. Does anyone have any other homework questions? Okay, all right. If there's no homework questions, we're just gonna keep going because we're insane. So last time we did 1.8, we looked at Venn diagrams some more, right? We looked at this stuff with the personality test thing. What I'm going to do is I'm keeping track of the ones I grade. I definitely haven't graded all of them yet, but keeping track of who's what to see what type of personality do we have the most of in this class, just because, so we'll see. Yeah, I had actual coffee this morning, so I think I'm doing better, and I feel better in general. So that those two things come together and help. Okay. So there's our Venn diagram kind of stuff that we talked about. I think we pretty much got the idea of how to put these together and how to read them. Okay. There's our pizza. And there's the homework. All right. So if nobody has any questions, we're going to get right into the next section. Dealing with these things are called newspapers. Has anyone ever heard of those? They're like historical documents. They still make these. Do you know that? Sorry. I'm very curious. I should have made a poll. Can you guys tell me, how do you guys get your news? I'm curious. I really should have made a poll for this, but I
think you did. Didn't we do this? Didn't we talk about this?
Nope.
We
We haven't looked at this section. I don't think I did ask you how you get your news, did I? Maybe I did. No. I didn't even give you guys.
I remember you asking.
You asked us a question, and I think we just answered sporadically.
Oh, okay. Man, that's them showing off my awesome memory skills. And that's not even because I'm old. I've had bad memory my whole life. I've been the absent-minded professor for a long time. But age is just going to make it worse and worse. Yay, Jeff. So I'm always concerned that news has become so politicized. It's insane. I used to joke that somebody would go to a barber and say, before you cut my hair, who did you vote for in the last election? And now I think we're basically there. So yeah, you said, oh, that's going to happen. Now, like, holy shit, it happened. So let's look at some of this. Here we go, just about. So here's this table. It talks about the daily circulation for newspapers over time. Can you draw any conclusions from this table? I mean, there's a very immediate conclusion you can draw. Oh, that's good. Devin's got a good approach. CNN, Fox, Al Jazeera. Yeah, I basically do the same thing, except I do watch some Al Jazeera stuff, but I watch BBC. You always want to watch something outside of the States to get an objective feel for things. Anyway, coming back to this problem. Am I sharing? No, I'm not sharing. I love you guys so much. Nobody said anything. Here we go. This problem right here. Can you make a conclusion? Is there a trend in the data? Okay, all right, thank you. All right, now let's focus. Everybody focus. Can you see a trend in this data?
It's decreasing.
Yes, so the circulation, which means the number of subscriptions basically, has been going well down over time, which makes sense. Okay, so that's a preliminary conclusion we can draw, is that the number of newspapers out there being subscribed to has gone way down. Now, I think this term has come up before, and I haven't really directly said this yet, but what does it mean? What's a scatter plot mean?
It's kind of what it sounds like, right? It's a whole bunch of dots
Yeah.
across a plot line.
I like it. So I'm not really sure the best way to do this. Let me figure this out. Well, I really hope you guys can see how I would do this. Are the years evenly spaced? Do you see what I mean? Are the years evenly spaced?
They're 2 years apart.
Good. So that would be a good scale for the years, 2001, 2003, 2005. What scale could I use? Let me see if they gave us anything to work with. Here. Now, to be honest, I don't have to start at 0, right? So see, I want to go from 37 about to about 55. So maybe I could start
5.
at 35, right? If I start at 35, if I go by fives, would that get me up 40, 45, 50, 55, 60? That gets me up a little too high, but that would probably do fine. Are you guys semi with me? I wanted to get up to about 55. So 40, 45, 50, 55. That's not too bad. And then I could do 2001, 2003, and so forth. Now, we're not going to do this problem. I could just plot the points, just like the problems, the one we just looked at. Okay. And obviously, we would expect to see a downward trend because the points should be going down over time. That kind of makes sense. All right, so let me clear this. So this is stuff we've done before. So now we're going to talk a little bit more about, so we've already kind of done stuff where we graph data. So now we're going to start talking about where do we get data from? So for example, if I wanted to say something about the average age of Grossmont students, let's say that we want to figure that out. Can we talk to every Grossmont student to find out their age? What do you think? Does anyone know how many Grossmont students there are?
Like what, like 20,000 or something?
Yeah, there used to be 20,000. I think right now we're about 16,000 or so. 16, 17, I don't know. I haven't looked at the last numbers. But that's a damn lot, right? I don't want to talk to that many people. In fact, what do we normally do in statistics when I have a big group I want to say something about? What would you call that big group? It's the entire
Population.
population.
General population.
Good. General population, the entire population. But in statistics, what do we normally take from that population that I want to work with?
A sample.
Sample. I love
sample.
it. Okay. So those are two words we all know from everyday life. So population is something that I want to say something about. It's the entire group I want to talk about, right? So for example, when they were doing the vaccine trials, right? And how did they figure out that the vaccine was effective? Well, they didn't give it to everybody. That would be a bad idea, right? Before they know. So they gave it to some brave people, a sample of people, right? And then they kind of kept an eye on the sample of people to predict what it would do in the population. So they used a sample to predict something about the whole population. I like it. So let me share this again. Keep forgetting that I'm not sharing. So population is all those things that we want to say something about, and the sample is the subgroup that we're actually going to work with. In the case of the newspaper circulation numbers, what's the population? So let's go back up here. Average daily circulation for newspapers in America. So what's the population for that? What would the population be for where they got that data from?
All the newspapers.
Yeah, just all American newspapers. All right, so it's all about American newspapers. Now, what's a way that we could take a sample? Like so we have all American newspapers. Can somebody come up with a way to take a sample?
We put the name of all of them in a hat and then pick
Yeah,
it
exactly. I love it.
out.
The old
We
put
pick
them
out
in
a
a hat.
random like couple.
I like it. Right. So the old put them in a hat. Sort of like picking somebody to sacrifice, put a lot. Let's not do that. So a sample could be drawn out of a hat. So a sample would be a subgroup of the population. And one way you could do them is to pick out of a hat. That's one way we could do them. Now, one of the main things you want your sample to do, and this only makes sense. The reason we take a sample is because normally we don't have the resources, time, money, whatever, to work with the entire population, right? Or in the case of vaccine, you don't want to give it to everybody before you know what it's going to do, right? So that's, so I want my sample to be representative of the entire population, right? So if I wanted to say something about all American newspapers, why would this be a bad sample, number 5? Why is this a bad sample? Why is it a bad sample? The daily newspapers from the 10 biggest cities in the
Too
US.
broad.
It only represents only a small portion, right? It doesn't represent the smaller cities as well.
Yeah, so the whole idea is representation, right? It does not represent all of American newspapers because I've picked from such a select group. Let me see. I don't know what the zombies is about. Stay with me now. To be representative. Now, this is interesting. For example, let's work with something we can see. If you guys were a sample, if I used you guys as a sample to represent Grossmont, why would you be a bad sample?
Too small.
Actually, no. It's a little small, but let's ignore that for a minute.
What was the question again? I'm sorry.
So if I wanted to say something about all Grossmont students and I used you guys as my sample, why would you guys make a bad sample? Are you just bad people?
We're
No.
we're like a centralized like students in just a math class. So like
Okay,
if you wanted
okay.
to really take a good sample, you would have to choose a whole bunch of students from a whole bunch of different classes, right?
There we go. We're starting to get there. Somebody else have a different. So that's one thing is you're all in math class.
Because this class is not required for most of the students, especially
Ah,
who
I like
finish high
it.
school.
Not everybody could take this class. So let me ask you this. Would every Grossmont student have a chance to be in the sample if I used you guys as my sample?
No.
No.
No, because not every student takes class this early. Not every student has to take this class. So forth, so on. I like it. So that's why you guys, I have to assume you're not representative because there are things that bring you together here now that could bias my results. Okay. Let me stop for a minute. So this idea of being representative is huge. It's huge. So this is bad because this would represent those cities, not the United States. How about number 6? Is that better?
Not really.
Isn't it?
Is it?
Yeah.
So is it fantastic? No. Is it better than 5?
Yes.
Yeah.
Yes.
Yeah.
It is better than 5. What's an immediate thing you could do to make this number 6 better?
It says one newspaper randomly choose from each of the 50 states.
That's right. So for anybody who thinks that's not really that great, why? Why is it not really that great?
Because every state has multiple newspapers. they-
So what's one immediate thing I could do to make the process I'm using in number 6 better?
multiple papers from multiple
Ah,
states.
so choose like 6 or 10 random newspapers from each state. Now that's getting really pretty good, right? You guys agree with me? If I
Yeah.
randomly choose a
Yeah.
certain number of newspapers from every state, that's becoming a much better sample, right? Okay, I like it. I like it. Okay, okay. Let me clear all this away so I can move. Bang. Number 7's obviously, right? I'm saying obviously, but it's obviously, is that good or bad? All newspapers affiliated with a national media conglomerate.
It doesn't
No.
choose independent newspapers.
Yeah, this is just remarkably bad.
Yeah.
Have you guys ever seen the clip of all the different news stations and they're all saying the exact same thing because they all have the same parent company? That's a little scary. Well, that's actually very scary, but we've been like that for decades now. So, what about number 8? This is basically that hat thing, isn't it? But this is a neat way to do this. All newspapers are listed alphabetically, and then every 10th one is chosen. What do you guys think?
That
Yes.
works.
Yeah,
You're getting
that's
a
pretty.
random sample, right?
Yeah, it's a pretty good random sample. The one thing I would change is I would start at a random newspaper and then do every 10th one after that. But otherwise, do you guys understand that's not a bad way to do it? The number 8 approach. Okay, I like it. Could you end up in number 8 having a state where you don't have any newspapers from that state?
If they have such a small number of newspapers.
Possibly.
Yeah,
Right.
totally. And that's not horrible, right? But that's interesting. This is random. This would end up in a random sample because everybody has a chance to get into the sample. But if you wanted to make sure that every state was represented, then you would have to do it more like this earlier one, right? Where you take so many from each state. All right. I'm getting a little too deep into this. I'm sorry. All right, let's keep going. Why now? They ask people how they get their news, and they give all these answers. Can somebody tell me why it would work to put this in a pie chart? Remember pie charts? Why would a pie chart work for this? What was the main thing that had to happen for a pie chart to work?
But the total is 100%.
Yep, total's 100%. I love it. Would a scatter plot work for this? Are there points?
There aren't points as
No,
percentages.
so a scatter plot would not work. A bar graph would work. You could make a bar graph for this, right? Make the height. This would be the tallest bar. This would be the biggest slice. Okay, I like it. How do you know it came from a sample? Well, look right here. They say the results of a 2015 survey. So you know it's a sample. It's not every adult in America, right?
You want to
All right. Maybe.
No.
Maybe. So now let's hello.
That's my teacher. That's my teacher.
All right, so let's look at this. Let's get into some more mathematical stuff. What we're about to do is we're going to create a little frequency distribution. What that means is it tells me how the frequency of data is distributed amongst the categories. So let's do this. This works exactly the way it looks. So what categories do I have? I have social media. I have internet. I'm not sure necessarily what the difference is. TV, print, and radio. So then let's see, social media. You guys with me out there? It would just be, I see one here. I see one there, and then I see another social media there. And then I see another social media there, and I see another social media there. All right, so you guys finish that out real quick. Finish out the tally marks. Go for it. I'll sit here and wait. I'm tired. I gotta take a break.
Sorry, what are we finishing off?
Yeah, you're finishing off the little tally marks. So for example, internet, I see one there, and then another one, right?
Okay,
Okay,
thank you.
sure. All right, thank you. Sure, sure, sure. I lost my track now. Two. Yeah. So frequency is just, putting the number down. There's 4 social, seems to be 9 internet. How many of them TVs? TVs kind of stands out. That's nice.
6.
So I really don't, yeah, 6. So I really don't have to do the tally marks. Are you guys with me? Because like TV, I see 1, 2, 3, 4, 5, 6. TV's nice. It kind of stands out. What about print?
4.
1. What'd you say? 4?
Yeah.
Yeah, it looks like 4. And then radio,
5.
5.
3, 4, 5. I agree. Cool. So let's double check here. 28 college students, right? So what should all these add up to be?
28.
Holy shit. And they do. Thank God. Check. So you're going to be making your own frequency distribution like we just did. And a real quick check is to add up the frequencies to see that they add up to be the total. So why is it called frequency? Because we count how frequently something matches the category. So what was the frequency that social showed up 4 times and so forth? Okay. Whoa. I don't mean to shock anybody. Okay. Now, let me erase this up here. So here's what I'm going to try to do. Let's see if this works. I want to keep track of that somehow. All right. So just looking at this, what's the most commonly used way to keep up with news?
Internet.
Internet. Do you think there's enough data to be able to talk about all college students?
There could be like a sample, but I don't know about all.
Well,
college
we got a
Yeah.
sample.
Yes, isn't it?
Oh,
We got a
sorry, I was
sample.
relating to.
That's all right. We got a sample of 28 college students. Did they tell us how they picked them? Did they tell us how they picked the 28 students?
No,
No.
could be their
So if
friends.
this is
or
trying to say
something.
something about all college students, we don't know how they pick them. 28's kind of on the small side, right? In fact, most of the time when you see a good statistical analysis, they're using around 1,000, 2,000 responses. That's normally considered a good sample size to make broad. All right, stay with me. All right. Now, oh, shoot. So let's see if I can do this. I don't think I can be this nifty. No, I'm not going to be able to be this nifty, darn it. All right, so let me do this. 49645. Let me see if I could do this. So I got social, internet, TV, print, and radio. I've got 49645. Okay. Let me erase this stuff. And now we can make this bar graph, right? A bar graph is used for name data. I will use a bar graph if the data I'm counting is name data. This is obviously name data, radio, TV, these are names. If they were numerical data, I would call my graph something different and it would look a little bit different. All right, so that's coming up. So how would I do this? Oh, I see why they gave me 2. Okay. So social media, I'm going to make a bar that goes up to 4. That's amazing. Let me know if you guys have any questions. You're going to have to be able to do this yourself, but it's nothing crazy. Print was 4. TV was 6. Internet was 9. And radio was 5. All right, so that makes it nice. So the visual is nice because I can just see the highest peak real quick. What's the difference with the second graph? Why did they give me a second graph? What's the difference? It's like those spot the difference things in the highlights magazines. Anybody see the difference?
Yeah, start with the 3.
For the
Starts
number
with
of
3. So let's see what this looks like. Social media was 4. Print media was 4. TV was 6. Oh, Jeff. I forgot they did something weird. TV was 6. Internet was 9. And radio was 5. So which one of these graphs makes the differences look bigger?
Start at 0.
That makes the differences look bigger?
If we start
Oh,
at
no, 3 makes the
3,
differences look bigger. It makes like the
Yeah,
student-
this one makes the differences look bigger, right? And this is a common, now believe it or not, people do this. News stations do this. Sometimes I wonder if they're not bright enough to realize they're doing it wrong, but most of the time I realize they know exactly what the hell they're doing, right? And most people don't even know to look for this. So if I start at something that's not 0, I can make my differences look much bigger than they actually are. All right, I like it. So if unfortunately, all the news is biased now. So depending on your bias, you can draw a display for your screen in different ways and make people feel different things. And if they don't even know what to look for, they just have an emotional response instead of a logical response, which really sucks. Okay, I'm going to clear all this away. So you guys have to be able to do this. Was this difficult? No. Do you guys agree? I don't want to answer for you, but is this a hard thing to do? No.
No.
Yeah. All right. So let's take a look at this other. Let's see if they have the other type here pretty soon. Blah, 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 blah. Oh, look at this. This is beautiful. All right. So now we've got, let's see, the number of visitors to different online news sources. All right, so I want to be able to graph this somehow, but I'm not going to make a bar graph. Now, this is not the best example for this, but it's just too bad for us. And in fact, let's not do this. Let me see, how do I figure this out? It's going to be hard for me to show you because it's on 2 different pages. But here's the idea. If I have numerical data that I want to show, so in this case, I want to know how many show up between 5 and 14.9 times. So if any of you guys are going to take statistics next, and I think quite a few of you plan on taking statistics, you will be making this kind of graph. In fact, I just did it with my stats class early in chapter 2 in their class. In that class, we're going to figure out how did they determine these numbers? How did they figure these numbers out? So in the class in statistics, we actually figure out the formula for finding those. Okay. So I think what I want to do, let's see. Yeah, I guess we'll try to do this. So 5 to 15, let me recreate this over here. I think that'll be easiest. Yeah, this will work. Okay. So if I have they're going to give me these, they're called classes. I have no idea if they said that on the other page. I think it went 5, 15, right? 25, 35, 45. Okay, I think that's right. So if you have your own book, you can flip back and forth easy. So watch how this works. So this is numerical data. I want to graph just these. That's the idea. I just want to graph how often these things happen. Okay, so let me see, where am I at? You can do it, Jeff. There you go, buddy. So I'm still going to have a frequency column. How frequently did a data point show up between these two values? This is going to kind of suck since they're not in order, but too bad. So it's got to be between 5 and 14.9. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Does everybody see what I just did? There's 15 times that a data point showed up in between those numbers. All right, I'm going to keep going if everybody's with me. So it's a lot like what we just did with the non-numerical data. It's the same thing. And so 15 to 24.9, let's see. Blah, 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 blah. Let's see. 1, 2, 3. 3, it looks like. Is that right?
Yeah, I got 32.
Yay! And then 25. So that'll be 1, 2, 3. Looks like 3 again. And then 35 to 45. Is there anybody? I don't think there's any 35 to 45. Looks like
No.
0.
0.
And then 45, that'd be 1, 2, 3, 4. Now, let me see if they gave you, hold on. Let me see if I could do this. I'll come back up here. Hold on. I want to see what they gave us. Okay, good. Okay. They do give us this. Shoot, I went too far. Sorry. Hold on. The reason there's a difference between the bar graph and what we're about to create. So what we're about to create, it's called a bar graph if it's name data, right? If it's name data, it's called a histogram if it's numerical data.
But are they the same?
Here's the difference. Since it's numerical, it will have an actual scale I can use.
Professor,
Sorry?
my connection became like unstable for like the past 10 seconds. The last thing I heard was if it was the same or not.
Sorry. So okay. Bar graphs use name data. Histograms use numerical data. There cannot be a gap on a histogram unless you have an empty class.
Good to go.
So on a bar graph, the bar graph we just did with like radio and all that kind of business,
Yeah.
there were gaps because who cares? They're name data. This gap doesn't mean anything. This isn't like a real scale if they're name data.
Right.
If it's numerical data, it's an actual scale. So I can't see any gaps between the bars unless there's like an empty category. And we do have an empty category right here, don't we?
Yes.
So how tall will the first bar be from 5 to 15?
A 15?
15.
15, 11. So my scale, that's the tallest bar, right? So what scale should I use here? Maybe. What's good scale for
5.
this? Yeah, let's try 5. So, well, 5, 10, 15. So maybe a little bit less than 5, right? Do you guys see that? 15 would be right here. I want to use a little more space. I really want you guys to understand. 5 is too big. Let's use maybe 3, 6, 9, 12, 15. Hey, now I've got some more space. I'm letting my graph breathe a little bit. I'm not smushing it. So from 5, is everybody with me? From 5 to 15, the bar is going to be up to 15 because that's the count. What about from 15 to 25?
Three.
3. All right, so it's going to go up to 3. Bam, right there, no spaces. What about 25 to 35? That's also 3. What about the next one, 35 to 45?
0.
0. So it's going to be empty. And then 45, this last one is going to go up to
4.
4, which will be just a little bit above 3. Okay. So the big thing you got to be careful about is a gap means something on a histogram. It means there was a place that had no data in it. It was empty.
Is that why there's also a gap between?
Sorry? I lost you. Uh-oh. Did I lose you or did everybody lose me? Oh, good. All right. Am I here? Tristan, you're so... Okay, there you go. Thank you. I've only got 2 people to look at to make sure.
No, I'm here.
Okay,
I'm
okay.
listening.
So say it again, Trisha. I lost you.
Oh yeah, no, my computer does that a lot. No, so I was asking because you were talking about the gap between 35 and 45. And I was wondering, is that why there's also a gap between like the first marker and the 5?
Yes, good. Because there's nothing here.
Okay. Thank you.
You're welcome. And the nice thing is, let me see, how do I explain this?
Professor, just
This distance right here from the 0 to the first class doesn't have to match your scale. I don't know if you guys are with me or not.
you can watch us at the picture number 8.
Say again. Sorry.
In the picture number 8, question number 8 has the table, the graph table.
Yeah, I know.
Okay, we can see it.
This is basically what we're doing here. So they used a scale of 2. That's fine. We used a scale of 3. It's all good, right? I like it.
So you said that doesn't have to match. So does that mean that it could start at 20 and then go by 5s?
Yes. Because it's not lying. It's just there's a lot of empty space. So it's not compressing anything. It's just moving the bars over so I can see it quicker. So I don't know if you guys can, has everybody got what they want from this? I'm going to erase this. Are you guys ready for that to happen?
Yeah, I'm good.
Yeah,
The
good.
spokesperson has spoken. Everybody's good? Okay. All right, here it
Wait,
goes.
just a second.
Yes. Oof, you caught me right at the last second. What's up?
I thought I was unmuted and I was just copying some stuff and I was like, wait, don't do it yet.
Okay.
Go
So,
ahead.
all right. So now watch this. Imagine I have data real quick. Just stay with me. Stay with me. Imagine I have data and it starts at, my data starts at 600. But then my classes go like 602, 604. You guys kind of with me? So let's say my classes look like this. Imagine having so start at 0 and then imagine going up by 2. When are you going to get to your data? Do you guys understand when are you going to get to where your data is? Oh, no, Jeff, you could do it. Way. I mean, way. So
The graph
what
would
I'm
be big.
sorry?
The graph would be too big.
It would be insane. So in this case, this is one time. Oh, I could actually make straight lines. Jeez, Jeff, look at that. All right. This is one time that it's okay. See, I can go 600, 602. Do you see how the scale isn't consistent from the beginning? But that doesn't matter. I'm just kind of like moving my histogram over so I can actually see it. I really want you guys to understand because I'm such a big, the scale is important. The scale is important. And I want you to understand why it's okay to not make the first step match. I'm just moving my histogram over so we can all see it. Okay, maybe. All right. Some of you guys like, I don't care, dude. Just tell me how to do this shit. All right, I understand. Let me clear this away. All right, so they gave us a little chart here, but we made our own. Okay, so here they kind of list the differences. Oh, crappity doo. Sorry, guys. The differences between bar graph. So it uses name data, categorical data. Uh-oh, what's happening? Oh, okay, I understand. Look here, right here. Include spaces between bars, no spaces unless you have an empty class, right? All right. And I forgot to put my labels. Labels is huge, but I was so focused on just, see here how they have the labels? You've got to put labels on your graph so everybody knows what the hell it's talking about.
Professor, we can start any point between 5 and 15.
How do you mean? Sorry.
You know, we have a
Yeah, why are you asking like why did this start at 5? No. Well, I'm sorry, I really don't understand the question.
sorry, question number 8.
Number 8.
Yeah,
What
if I
about?
want to draw the line, the graph here, the 5 until 15, I can do it anywhere in the middle.
No. It's got to be from 5 to 15. Now, there is one thing I don't like with the way they did their graph here. There should be some space. 5 should be over a little bit.
Oh,
But then
okay.
when you make your bar, and I've forgotten how tall, I think this was 4, right?
No,
When you make your
this one
bar, it's got to
15.
go. Huh? Oh, 15.
This one
That's right.
15.
All right. I think this is your question. When you make your bar, you've got to go from the first number all the way to the last number, so that the next one starts at 15 and goes to 25, and there's no gaps, right?
Okay, yeah, that's my question.
Yeah. Okay.
Okay,
I like it. I like it.
thank you.
Okay. Let's see. Who cares about this? Let's see. Blah, 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 blah. Oh, all right. Let me see. What time is it? I don't want to. All right. Good. Let's do one more thing here. There's something called stem and leaf plots. Now, you got to love that name, right? There's actually something else called box and whisker plots that we're going to do later. So let's look at stem and leaf. Look at this data right here. All right, I'm just going to tell you this. The stems, so I'm going to use stem leaves. All right, the stem would be the first digit. So what's my lowest first digit in this data? What's the lowest first digit? Somebody help me out.
5.6.
4. 4.
Looks like 4 right there, right? The lowest first digit is 4.
Mhm.
And then what's the highest first digit? Looks to be
6.
no?
Oh yeah.
7. Okay, now watch. Where am I? There's only 140, is that right? Yeah. So 49. So the stem is the first digit and the leaves are the last digits. In this case, I only have 2 digits, so that's kind of nice. And then what about 5? Let's see if we can put these in order at the same time. Oh, this should be exciting. I see a 51 and another 51. Are you guys? And another 51. That's 3 51s, right? So 51, 51, 51. And then do I have any 52s? Yeah, 1, 2, 3. Looks to be 3 52s. So 2, 2, 2. And then I see a 53. 1, 2, 3. I see 3 53s. 3, 3, 3. I mean, do you guys get the idea of this? This is remarkably simple idea, right? I have not given myself enough room where I put it to continue going, which kind of sucks. I wish I could plan ahead better. Because this is going to be kind of a long one, right? The neat thing is, sorry, go ahead.
This one works with the only numbers has a 2 digit. What about
No.
numbers has a 3
It works for anything. It works for anything. So let me show you an example. And let me do it up on the board, I think. I'm going to get off my ass. Has everybody got what they need from this? Does everybody understand? You just keep going till you get all the data put down here. And if you put it in order, it's a quick way to put data into order, right? Just by focusing on the 40s, the 50s, the 60s. All right, I'm going to clear this away. Let me know if that's bad. Here it goes. In fact, I'm just going to close this down. Bam. All right. Let me turn off the moon. All you flat earthers, I'm going to turn off the CGI moon. Let's see. Hold on. CGI. Bam. All right. Now. So this is the neat thing about stem and leaf. I did leave one thing off that I want to talk about right now. Get rid of all this weird shit. So what if my data look like this? I want you to watch this. It's kind of cool. What if my data looked like 409, 412, 417, 423. All right. So my data looks like this. Now, why? Now, I really want you to get this idea. Stem and leaf is very simple and it's very flexible. Would it make sense to have my stem be 4? No, because then there would just be one big ass line. Can somebody see what I should make my stems?
I think
And you guys might not. Sorry?
40.
Yeah, like 4.
Yeah.
Now I can use 40, 41, 42, 43, right?
Uh-huh. I understand.
And then the leaves would be 409, 4127, 423, 425, 426, 437, 439. You guys?
Yes.
Now, let me stop for a minute. Go ahead, Trish. So what I want you to realize is there isn't a standard way to pick what these are. You pick what these are based on what the data is, right? Why would I make them 4, 5, 6 when they only have 4s? All right, that's dumb. So it would make sense that you make these the stems. Now, the one thing I need to put down here so people can read this, like if I gave you a map of how to get from one place to another and you're walking, what would you want to have on the map? You got to walk from here to here. I'm like, okay, I know how to get there, but I want to know
How many paces?
Yeah, I
Yes,
want to
three
know
days
how,
and-
I want to have a scale, right? I want to know how far an inch is an inch a mile or is an inch 20 miles? Because that's going to mean a lot to me if I got to walk there. Yes. So
Yes.
this only makes sense if I have a key. So for example, I could say key 40 line 9 means, get out there, Jeff. 409. Now somebody could read this without seeing this data. Okay. Let me show you another example. So what if I had 5.7, 5.9, 6.2, 6.3, 6.5, 7.1, 7.4, 8.2. All right, stem leaves. What should you use for your stems?
5, 6, 7, and 8.
Good. And the leaves would be 7, 9, 2, 3, 5, 1, 4, 2. And what would my key be? 5, line 7 is
5.7.
what does that mean? What data point does that mean?
5.7.
5.7. See, now, since I gave you that one thing, now you know that this is 7.4, for example, because I can see the key. All right, let me stop. Does everybody kind of get this idea? It's kind of cool. Now watch. Does anyone not get the idea? Because I'm about to change something. Okay. What would I change here if my data had been this instead? $57, $59, $62. What's the one change? Do I have to change this?
The point in the 5.7.
You have to
Yeah,
change.
I just changed that. That's it. That's the only change I have to make, right?
Would it
I
be
have a quick question.
Go ahead.
I guess semantics. If I'm writing this like for homework and you see like on the leaves side, like for me to continue my, like for my knowledge, if I put commas in between like the 2, the 3, and the 2 and the 3 and the 5, is that okay? Or is that
No.
considered
That's fine.
okay? Just
It's
okay, I'm just making sure.
convention to not include commas. So then you can ask, let me show you one more example and I think we'll call it a day. Let me show you, everybody ready? I'm going to show you one more example. It kind of relates to what you were just saying. All right, here we go. So what if my data look like this? Actually, I want to do two things with this example. Ooh, Jeff, watch out, buddy. Well, shit. I guess I'll do one thing. All right. So obviously, hopefully everybody agrees the stems would be 4, 5, 6, 7. Is that cool?
No, I think
Yes.
45, no?
It doesn't make sense to make the stems 45, 46, 51 because one thing I want to be able to do with this is to accumulate things together. And if I did 45, 46, 51, each data point gets its own entry. That doesn't make any sense.
Okay,
Do you guys see that?
okay. Done.
So you're not.
So there's a
plugging
bunch of 400s, there's a bunch of 500s, there's a bunch of 600, well, not a bunch, but, right? So then, now look, I could do this. So you just have to put a space. And I'll show you, there's even a better way to do this, but I'll start with this. So then your key would be for line 50 is 450.
So is it safe to assume, like, okay, since I had the question about the comma, if there were a comma that would be representing like hundreds? Is that the thinking behind that? Like it would just be like,
You ready?
like 5, like, okay, yeah, go ahead.
No commas. Period. Is that cool?
Gotcha, yeah.
Good. All right. Now, any questions about what I just did up here? Does anyone see? I want to see. Last question for today. Does anyone see an improvement over what I've done? Let me show you. Here's the improvement I could make. Let's see if you guys are cool with this. 5, 6, 1, 4, 7, 1. You could do it, Jeff. 1, 5. There we go. Then my key would say for line 5 means 450. Do you see how much work the key can do for us? All right, I'm going a little deeper into this than I really need to, but what the hell, why not? I kind of want you guys to know how much flexibility there is with this. The key does a lot of work. So now if somebody came along and they didn't know this and they said 6-1, all right, that must mean 610. I can read it.
But what's the difference between 61? It's not 610. It's the same
What do you
key.
mean?
Isn't the same key? 61
Obviously.
and 610.
Stay with me. Obviously, if there was a data point that looked like this, I would not be able to set it up like this, would I? Do you understand?
Okay, yeah.
So why did I set it up this way? Because there was no data point like that. All the data points ended in 0. That's the only reason I could set it up this way.
Okay, I understand.
All right. I like it. And this again, now look real quick. If you turn your head like this, doesn't it look like bars? Doesn't it look like a histogram? So that's another thing that stem and leaf does, is it kind of naturally makes its own histogram just by listing the numbers out. All right. All right. No, maybe, no. All right. I think that's probably enough. That's probably all you can take of that statistics at the moment. This is not the exciting statistics. This is kind of the boring statistics, but oh well. I like stem and leaf plots, but that might be me. Your number relies on the key for sure, yes. So the key does a lot of work. And that's why if you don't put a key with your answer, you don't have a complete answer. Okay. All right, I think that's enough for today. So tomorrow we'll finish up section 1.9. We're going to look at some stuff online, some neat statistical analyses online. We'll look at that tomorrow. Otherwise, let me know if you need to hang out. If you don't need to, you're free to go.
Have a nice day, Professor.
Take care.
See you next time.
Oh, sorry.
Oh, see you next time.
All right, man.
Thank you.
Sure. All right. I'm going to head out. Oh,
Quick question. What
Yes.
were all of the letters above like what you were working on?
all the letters. All the letters. Where?
It was on page like 123, and so you were going off of the like data chart, but there's like a bunch of letters like C, 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 A, D, E, C.
Yeah,
C.
that's for a different problem. We didn't do that problem.
Oh, okay.
Yeah, so that you could do that problem the same way we did the radio and the social media problem, right? You just have to count how many C's and how many A's.
Okay.
Cool. So yeah, I just didn't feel like doing that example.
The only reason I ask is because it was on the applications for the homework.
Oh yeah, so like I said, it's just like the radio, social media problem we did. You make a yeah. Oh, I see. Number 2. So you make a column T D O P. I think that's all of them, and then next to it you put how many T's, how many P's, how many D's. Yeah. So let me see. What was this? Oh, they tell you up there what they mean. The New York Times, the Post, the Daily News. Okay.
All right. Thank you, Professor. Have a great day.
You're welcome. I'll see you tomorrow.
Tomorrow.
Daniela, you okay? All right. I'm going to head out. Bye.